Everybody have enough time? Pass those in. So, what are Joe's rules?
I will feed my calf and then the second, third one I will reproduce.
We'll have the next calf or reproduce or commit to the next generation. What do you got for rules for feeding non-structural carbohydrates to lactating cows? Go ahead, sir.
Don't overfeed too much. Your main goal to limit, you're gonna push towards the mid-30s. If not, you're gonna get some really bad issues like acidosis, and that's caused a really big problem in your herd.
Okay, so that first one, don't overdo it. Anybody else got anything different? Don't overdo it. We watch our cows, make sure that we balance things out. We want to get that fermentability in the rumen just right. So we're having maximum extraction of energy, most digestible energy we can out of the feed, and not overdoing it and messing up with our cows. Rules for feeding NDF to our lactating cows. What do we know about that? Anybody have any suggestions? Yes, sir.
My answer is not outreach, but I said, make sure like what's your NDF source, like your haylage, make sure it's cut to a correct length, like 3/8, like 3/8.
Okay, that's one rule. Anything else? Make sure we chop the right length. What else? Gotta have a minimum amount. It's gotta be in the right form. Gotta make sure we stimulate that chewing, maintain the rumen health.
I also said like promote the rumen mat, with like the sweet
Yeah.
size of the.
We need enough to make sure that the rumen is working right, the mat to hold everything back, the scratch factor to stimulate rumination, the scraping or scouring to keep the rumen walls clean. Okay, so this week we're gonna do a little bit more dry matter math, and then we're gonna introduce our ration balancing, which will take up a lot of the rest of our lab time. So how much dry matter is in feed? We've already done that, right? Last week, we have an as fed amount. It's got all 6 ingredients in it, or all 6 nutrients in it: water, fat, protein, carbohydrates, minerals, and vitamins. We take the water out mathematically, and we're left with dry matter pounds. Now, what we need to do is break up that dry matter into various fractions. We're going to do this in a number of different ways from here on out for the rest of the semester. So we need to take the water out. We've done that mathematically, and then we have to break this up into different feed components, different nutrient components as we go forward. So it's going to be similar to how we calculated the dry matter pounds. Instead, we're going to move the dry matter pounds over here. We're going to multiply by the nutrient concentration, and that's going to give us the nutrient pounds in that feed. We've alluded to this. Nutrient intake is the most important thing. We have to make sure that gets done every day. So we're going to take our dry matter and we're going to split it up into different fractions. So if we look at an example here, we might take 100 pounds of hay crop silage dry matter, and we've got the various nutrient fractions in there. So we've got carbohydrates represented as sugar and starch and NDF, protein as crude protein, our fat, and our ash is our mineral content. What nutrient are we missing? The sick, well, water has been taken out, so yeah, that's missing. What's the other one?
Carbohydrates. Oh, that's right.
Sugar and starch and NDF. Vitamins. Vitamins are basically in the feed, so we don't worry about that on a weight basis. There's so little of it there. So we're going to do this a whole bunch of times, so you'll have multiple opportunities to write this equation down. So instead of as fed pounds, we got dry matter pounds. Instead of water, we've got percent crude protein, and that gives us crude protein pounds at the end. So what we have to do to partition our feed into nutrients is a two-step process. So we start with the as fed pounds. Last week we showed you how to split out in step one the water pounds from the dry matter pounds. Step two, we're going to take that dry matter pounds and split it up into these protein fractions. For this class, those fractions will add up to 100 more or less. Do that happen in real life? Probably not. We get things like pectins that aren't accounted for, organic acids, some just lab errors that might not add up. But for this class, we're going to make sure everything adds up to 100%. So you can double check your math at the end of it all by saying, does my pounds of protein, my pounds of sugar and starch, my pounds of NDF, my pounds of fat, my pounds of minerals add up to the pounds of dry matter we started with? If those percentages all add up to 100%, this total should equal that. And then if we add dry matter to water, we should get our as fed pounds that we started with. So let's fraction out a feed on the board. Those of you listening to this on YouTube, I will include the pictures of this whiteboard in our posted materials. So let's start with a feed. So we're going to start with an as fed ton. And we'll start with corn silage. We have a ton of corn silage. That's going to have a certain amount of water in it. Certain amount of dry matter in it. Let's go with 65% water, 35% dry matter. Then we have the dry matter broken up. Percent of the dry matter. We'll have our fractions. We'll start with protein. Sugar and starch. NDF. Fat and ash. So dividing up the dry matter into 5 different categories. We're going to say the protein is 10%. Sugar and starch, 37%. NDF, 46%. Three for fat, four for ash. So that adds up, if I'm doing my math right, to 100%. I've got the entire dry matter accounted for. So step one over here on the board, we take that ton, which is what? How many pounds? 2,000. 2,000 pounds of as fed. Multiplied by 65 divided by 100 or 0.65 is going to give us what? How much water is in that feed? £1,300 of water in that feed. Almost 2/3 of it is water. One of the reasons we can't move, it's not worth moving corn silage long distances because you're moving a whole lot of water. We could dehydrate the whole silo after it ferments. We might be able to do something, but. So we've got 1,300 doing the same thing. We start out with 2,000 pounds as fed. $35 divided by 100 or 0.35. That's going to give us what? 700 pounds of dry matter. And we can double check our math. If these add up to 100%, this should add up to what I started with over here. And it does. 1 ton. Everybody understands step one. So we go to step two. We're going to take our dry matter pounds, multiply it by our percentages, divided by 100, and that's going to give us our pounds of dry matter for each of our components. So if we multiply through for each of these rows, 700. So we're going to partition that 700 pounds out into 5 different components. So 10% or 10 divided by 100, 0.1 times 70 gives us what? 7 pounds. Sugar and starch, 37 over 100. 0.37 times 700 gives us what? 259. Does everybody agree with that? 47.47 times 700 gives us what?
320 pounds.
322. 3%. 21 and 28. Checking our math. 3, 2. I think that comes out to 700 again. So 700, 699. If we're rounding off 701, either way, we're close enough. So that pile of 1 ton of corn silage has 1,300 pounds of water, 70 pounds of protein, 259 pounds of sugar and starch, 322 pounds of NDF, 21 pounds of fat, and 28 pounds of minerals. Everybody following that, moving through. Feel comfortable, you could do it on your own. Okay, so let's switch over. Let's do a ton of hay. Take a picture of it before I get rid of it. Somebody needs it. Okay, so we're gonna redo. We've got the same template as we had before. We have different proportions. So this time we're gonna do 1 ton of hay. Probably 3 big round bales. We brought those 3 round bales in here. Let's use for our water percent 12. That makes our dry matter 88. And for our protein, we do 10%. Sugar and starch, 15%. NDF, 65. And 6%. So again, that adds up to 100. So I need you to fill in the blanks. What is that? 14 blanks. How did I do? Everybody coming up with those numbers I have on the board? Everybody see how to do that? Any questions? Your homework will be to do 6 of these problems. If I give you the inputs like we just did, can you go through and figure out the rest of them? Okay, so we've got, it's posted up on Brightspace under the lab. But here's a hard copy of the same. First one, 2 p.m. So it's helpful if you can go to 1 decimal place, just from a grading standpoint. But whatever you feel comfortable with. So we've got 6 different feeds there. I don't think I use them all in these examples, but we're going to play with hay again, corn silage again, haylage, hay crop silage. We've got a heifer grain, we've got a TMR, and we've got a soybean meal. So you go. Use the amounts of feed that they talk about there and break that poundage up into its various components. So water, protein, sugar, and starch, NDF, fat, and ash. So any questions about that assignment? Okay. So next up, we're going to talk about balancing rations. So it doesn't matter whether you do it by hand, whether you do it with a computer, whether you do it with a spreadsheet. All these things, principles will apply. This is the mental gymnastics we want you to get good at. So the first step we're going to do is define the feed or feeds that we are using. We need to know what composition those feeds are. We also should know on some level what our inventory is so we know the maximum rate we can feed this at. We may come out with a balanced ration that says 20 pounds of corn silage, but maybe our inventory says, well, we can only use 15 a day and get through to after the next harvest, after the next fermentation. So figuring out what our feeds are. So most of our ration balancing programs will ask for that information first. You build your feed library of the feeds that you have on your farm. Second, you define the animal or animals. Usually ration balancing programs will start with a single animal and you describe all of the things that animal is doing. If she's milking, how much is she milking? What is the composition of her protein and fat for that milk? Is she pregnant? Is she gaining or losing weight? How do we account for all that? So what is she doing? And then what are the nutrients associated with each of those activities? What nutrients does she need to accomplish those activities over a long period of time? And then the third is we balance the ration. We have the feed side, we have the animal side, we bring them together and they interact. As a general rule, we'll balance for NDF first if we're doing ration balancing programs. As we get toward the end, We'll do that when we have our computer-aided ration balancing. Energy and protein are usually done simultaneously. Most people say, well, you do the protein, the energy first, then the protein. Well, yes and no. You sort of have to do both at the same time to get a good balance. You save your minerals and vitamins for last. Usually what I'll do is I'll say my mineral pack is going to take up 1 pound. Mineral and vitamin pack is going to take up 1 pound of my dry matter intake. I balance for my dry matter projected dry matter intake -1. And then after we've balanced that ration, we step back and say, okay, does this ration make sense? We'll have rations this semester that will balance on paper, but will probably kill the animal. Acidosis. Do we have the inventory to make it last? Is it safe for the animals? We put too much distiller's grain in the diet, they're going to go off feed, the rumens aren't going to work the way they're supposed to, and we're going to run into trouble. So you kind of have to take a step back. Artificial intelligence doesn't know how to balance rations yet. Take a step back and say, okay, does this look like a good ration? So it's always a good thing to take a step back and make sure that it makes sense. What we're going to talk about is the substitution method. And you're really going to use this whenever you balance a ration. What do I have to substitute into my diet to make a pile of feed on the ground that satisfies all the nutritional needs of that animal? So with a substitution method, the mathematics require that we balance the same number of nutrients as the number of feeds that we're using. So this is okay with 2, 3, 4 feed ingredients, but as we get up to 5, 6, 8, 10, the mathematics just become unwieldy, and then we say thank God for computers. The nutrients we will focus on when we're balancing rations over the next few weeks is the dry matter intake. How much are they consuming? We'll measure our energy. Today, we're going to use TDN as our energy measurement, percent of the feed that is digestible. And crude protein. Those are the 3 nutrients we are going to work with for the next couple of weeks. So that's defining the animal side. What is your dry matter intake? What are megacalories of energy or pounds of TDN that she needs? What is her crude protein pounds that she needs? Then we bring our feeds in. We're going to work with the nutrients, same number of feeds, and we're going to put feeds into 3 different categories when we're doing this. So we're going to have, one is going to be our forage, whatever that may be, corn silage, hay, haylage, some sort of silage, whatever it is. That feed is going to be low in energy, low in protein, and relatively speaking, should be low in cost. If we can balance a diet with just the forage, great. Well, especially with our lactating cows, we're going to have to bring in other grains that are going to help balance things out. So the forage is called our 1 feed. Our 2 feed is our energy feed. So it's going to be high in energy, low in protein, and usually has a slight increase in cost associated with it. So what might be in this category when we call it an energy feed? Remembering back to your feed ID, what might we want to focus on for energy feeds? What categories might fit into that category?
Like soybean meal.
Concentrates.
Certainly concentrates, not soybean meal. We're looking for something that's high in energy, low in protein. What fits that bill? What? Some byproducts will fit into that category. What's the cleanest one to fit in there? Anybody guess?
The corn sandwich.
Nope,
Yeah.
that's a forage. What'd you say? No,
Like canola meal. Like
no. Cereal grains, corn, wheat,
all your
barley. So the high, low, remember?
Yeah.
So you got those two there. So usually we're dealing with some sort of cereal grain, but again, a lot of different things will fit into that category. Our number 3 feed is our protein feed. We want something that's high in protein. Protein is usually the most expensive thing we have to buy. And correlated with that high protein, we also have high energy. So what's going to be in that category?
Like your roasted, not roasted soybean. But
Roasted soybeans would fit in that category. What else? Soybean meal, like you said before. Corn gluten meal.
with your fuzzy cotton seeds, like your whole fuzzy cotton, not whole fuzzy, but
Yeah, it would probably fit those two categories there, but you'd be feeding too much oil and you mess up the ration. So that's where we go back to that final step. 20 pounds of cottonseed is just not going to get the job done. It may balance for protein and energy, but it's too much fat in the diet. So we have those 3 things there. So the steps that we go through to balance a ration, we take our first feed and we try to balance the ration. We ask, does it satisfy dry matter intake? Does it satisfy energy? Does it satisfy protein? Most of the diets we will present to you, the answer is no. But if I could get it done with one feed only, that would be my cheapest ration. That would be the best ration. If that doesn't work, we'll try bring in feed number 2, our energy feed. And then we'll balance the ration out, see if it works. If it doesn't, we go on to our 3rd ration and add that protein feed, that number 3 feed in to get that through. So it works like this, and I think that's what's in your handout. We balance ration 1 with feed only, feed 1 only. If that doesn't work, then we move on to the 2nd ration, where we balance with feeds 1 and feed 2. If that doesn't work, we move to our 3rd ration and try 1, 2, and 3. So we're substituting as we move down. We're taking out some of 1 and putting in 2. We're taking out some of 2 and putting in 3. We're trying to create a pile of feed that for that day will satisfy that animal. So I'm going to start with a visual example. We're going to do this ration 3 different ways. Everybody comes to learning, everybody learns a little bit differently, but I'm going to do the same ration with a visual representation, with a spreadsheet, and then with the form that we'll be using for most of the semester. So we've got 3 different feeds. We've got hay, corn, and soybean meal. So we've got our hay. 1 pound of hay is going to be 4/10 of a pound. Each of these dots represents 1/10 of a pound. 4/10 of a pound of TDN and 1/10 of a pound of crude protein. So this is what's in 1 pound of hay dry matter, you've got 4/10 of a pound of energy, 1/10 of a pound of protein. So if we look up there, we're 40% TDN, 10% crude protein. We take 1 times it by 0.1, we get 0.1. So that's where those numbers come from. Corn is going to be 80% TDN for this example and 10% crude protein. So I'm going to use this bottle to represent 1 pound of corn. So the bottle is 1 pound of corn. In that 1 pound of corn, I've got 0.8 of a pound, 80% is TDN. So 8 dots, each adding up to 1/10 of a pound. Protein, the red dot, we're going to have 10% of 1 pound is 1/10 of a pound of crude protein. So 0.8 of energy, 1/10 of protein for that corn. Soybean meal, we are at 80 and 50, 80% TDN, 50% crude protein. So looking at 1 pound of soybean represented by this bottle, 1 pound of soybean dry matter, I guess is important to remember. We're balancing on a dry matter basis. 0.8 for our energy, 0.5 for our crude protein. So what you're saying, well, that adds up to what? 1.3 pounds. Some of the protein could be used as energy. So that's where that higher number comes from. So we have our 3 feeds. What we're going to try to balance out there. So our requirements are 3 things we're going to balance against. Our dry matter intake for this heifer, Holstein heifer, probably about breeding age, somewhere in there, maybe a little past. 15 pounds of dry matter intake, 8 pounds of TDN, 1.9 pounds of crude protein is what she needs to stay alive and to continue to grow and hopefully start that pregnancy off. So we have those 3 things there. So what we're going to do is try those 3 rations in order. So what is our first one? What is our first ration? What do we do? We try just feed 1. So which one do you think is going to be feed 1 out of the feeds we have? Hay is going to be our forage. It's low in energy relative to the other 2, low in protein relative to the other 2. So we're going to ask, is this 15 pounds of hay enough to get the job done? So if we look at it, we've got the thing here, we got 15 pounds of intake. 40% of that is going to be TDN. So what's 40% of 15? Something less than 8 pounds, right? It's probably somewhere in that 6.5 range, somewhere in there. So the ration didn't balance out. We can't do that with just this feed, just the hay. So if we do some substitution, step 2, I want to balance with my first feed, which is my hay. What is my second feed? Corn, high energy, low protein. I want to take out a certain amount of hay, put in a certain amount of corn, and try that. So I'm going to take out 5 pounds of corn or hay. And I'm going to bring back 5 pounds of corn. So are we at 15 pounds? Yep, we're still there. Energy, if we do the math, yes, we're okay. Protein. What do we know about this pile of feed that's sitting here attempting to feed this animal? Is there enough protein in here to satisfy her needs? How much is in here? A is 10%. Grain is 10%. What's 10% of 15? 1.5. There's still protein in all this, but not enough. We don't have 1.9. So I have to proceed to my third ration, where I try to balance with hay, corn, and soybean meal. Now, if I take 1 pound of corn out and bring back or put in, substitute in 1 pound of soybean meal, what happens to our energy? Stays the same. We have the same amount of energy in this feed as we do this feed. So taking one out, putting back in, the energy remains the same. If we're dealing with protein, what happens? I take out what? Taking out the corn, I take out what? 1/10 of a pound comes out, and then we put back what? 5/10, half pound. So we were at 1.5. I'll take this out. What do we got? 1.4. If I substitute that pound back in, where are we? 1.9. Are we balanced? This pile of feed right here is what the cow needs to eat each day to meet her needs. Now you're saying for a heifer, that's an awful lot of grain. Yeah, it is. But it's an example. You know, most people bring corn silage in to get those things done. So does that make sense? Visually. So what if we were going to do that a little bit more mathematically? We have, and this is up on Brightspace, quantifying the balance. So this is in a spreadsheet. I've got a spreadsheet with different steps along the way. I've got the given, so all the parameters that are given. Then I've got trial ration 1, trial ration 2, and trial ration 3. I've got my protein colored as red, my energy colored as green. This is where I'll put in all of my energy. This is where I'll put in all of my protein. I'm using different colors for each of the feeds, kind of that tan color for the hay, the yellow color for the corn, and the blue for the soybean meal. So we have our requirements. We have the pounds of dry matter in the particular ration. We haven't got to the ration yet. And then all of these feeds are 90% dry matter, and then the same TDN and crude protein that we had before. So I've got there. So we've got 1 through 15 across the top here. What does that represent? Anybody want to guess? That's going to represent her dry matter intake. Each of those columns is 1 pound of intake. So first pound, second pound, third, fourth, fifth, all the way up to our 15th pound. Each of those has 10 parts there, 10% of a pound or 1/10 of a pound for each of those squares. So if we look at hay, we've got 1, 2, 3, 4 tenths. TDN in 1 pound of hay. Corn, 1, 2, 3, 4, 5, 6, 7, 8. 8 tenths of each pound is energy. that the animal can use. Same with soybean meal. Crude protein, 10% crude protein, 1/10 of a pound, 1 square. For every pound of hay dry matter. Same with corn, same crude protein, same amount. 1/10 of a pound in every pound of corn. Soybean meal, 5/10 of a pound for every pound of soybean meal. Does everybody understand the setup? So substitution rations, we take our first trial here. We've got our hay. Bring that up. Going back to start over again. Is this pile sufficient for our animal? So if we put that in our spreadsheet, we look at our TDN. So we're feeding hay, the color tan, all the way across for all 15 pounds. Each of those pounds is going to give us 4/10 of a pound of energy, TDN. That's going to work out to 60 squares. 60 squares equals how much? How many pounds?
6.
6 pounds. So we've got 6 pounds of TDN down here, every pound of hay. So that color going across the top. We got 1/10 of a pound of corn or 1/10 of a pound of protein, 15 squares, 1.5 pounds of crude protein. Are we balanced where we need to be? So we're 6 pounds of TDN, we need 8. We're at 1.5 pounds of crude protein, we need 1.9. So we have our first ration, we're just using our feed 1 up here, 1500. So we know that didn't work out. So we need to go on to ration 2. Ration 2, we take some of that hay out and we bring in corn. We are substituting corn for hay. So we've got 10 pounds of hay, 5 pounds of corn. So in our ration here, we take out 5 pounds of hay and we put in 5 pounds of corn. Does everybody see that? Is that visible back there? Or do you need to move up for a couple minutes? So we take that out. So we have the 11th, 12th, 13th, 14th, and 15th pound are now corn for both energy and protein. The ration is 5 pounds of hay dry matter and 5 pounds of corn dry matter. So now we have 80 squares in there filled up. So when we substituted, we take out hay and bring back corn, what do we gain with each trade? If I take out a pound of hay and I put back a pound of corn, what do I gain in energy with each pound trade? 4/10 of a pound gain. The pile on the table goes up 4/10 of a pound of TDN every time I make a substitution of 1 pound. So you can see that here, 1, 2, 3, 4. We do that substitution. We're up. So where are we with energy in our diet? No, we're more than we were last time, right? We're at trial 2 here. If we compare previous So here, help, I got out of the way. So here to there, we filled in this area here. We've gained 20 squares, right? So we're up to 80 green squares. So 4 squares for each of the pounds of hay that are still in the diet. 8 for each pound of corn we brought in. So where are we from an energy standpoint? How many pounds of TDN? 8. So we're okay now, right? We've got that here. What about crude protein? Was there any gain by substituting with protein?
No.
No, it's exactly the same. We take out 1/10 of a pound, we put back 1/10 of a pound. We have the same amount of protein we had before. We're at 1.5, 15 squares. We're still 4/10 of a pound short. So it means we got to move to our third ration. So as we said before, we're going to take out 1 pound of corn. We're going to bring in 1 pound of soybean meal on a dry matter basis. And we're going to see what that does. So taking that 15th pound, we take out 1 pound of corn, we substitute in 1 pound of soybean meal. So we take out the 15 pounds of corn, put in the soybean meal corn there. So what's happened to our energy? We take out 8, we put back 8/10, the same, right? So that hasn't changed. What about our protein? So we take out 1/10 of a pound, we put back 4/10 of a pound. Now we're balanced. So in a systematic mathematical way, we start with a basic 1 feed or forage, and then pull stuff in, put stuff back, substitute until we get the balance. And if we do this in a stepwise fashion, we should be able to balance the ration. And when you're doing, like with a computer that's balancing like 20 different nutrients or 100 different nutrients, whatever it is, you're constantly thinking, what do I have too much of? What do I have not enough of? What do I have to take in? What do I have to put back? What do I have to substitute to get that pile of feed where it needs to be? So that visual representation, this spreadsheet is up on Brightspace. Is that helpful from this to that?
Yeah.
Okay, the next thing we're going to do is we're going to learn how to use our balancing form. So we have a couple different forms. This one's going to be for dairy cattle and TDN. So I'm guessing you're going to want to move through one to write on, one to keep as a blank. We'll have lots of these floating around, so if we look at this ration balancing form, you'll notice that there's steps 1 through 8. So look at the one side that has step 1 at the top. So we're going to first determine the nutrient requirements for the animal described. Define the animal. Step 2, we're going to find the nutrient composition of the feeds to be used. So we have a table there we need to fill out. We'll explain that in a minute. Step 3 is our first trial ration. We're going to try to balance with just our 1 feed. We compare that to requirements, see if it works. If it doesn't, we go to step 4. And this is how we determine how much feed to substitute. we need to first figure out what the substitution is. If I take 1 pound of this feed out and put another pound of this feed in, what do I gain? And you hope you gain something because you're usually short. And then how many pounds of that feed do I have to substitute to get the job done? Once we have that information, we go over to the flip side. Step 5. We're going to run a ration with just feeds 1 and 2. So we'll figure out how many pounds of each of those we feed the animal and how many pounds of each are in the pile. We pull the information for the previous side. We figure out the TDN pounds provided. We figure out the crude protein pounds provided. Total those up from the 2 feeds and check it against the requirements. Does it fit? If we are still short on feed, we need to proceed to step 6. There will be sometimes a semester where step 5, you're done. If you've got excess of TDN and crude protein and enough dry matter intake, you're done. But if it isn't balanced, usually you're short on protein. We go through the steps to figure out what do I gain with each substitution? How much of the protein feed or the number 3 feed do I need? And then how much do I substitute against feed 2? So that's going to give us number 7, our feed 1, 2, and 3 ration. We put the pounds of dry matter in there, calculate the pounds of TDN provided by each of the feeds, the pounds of crude protein provided by each of the feeds. We total those up, we compare them to requirements, and we decide whether we've got a balanced ration or not. Balanced ration is considered balanced if we're within 5%. So plus or minus 5, you can probably go even 10, but let's do plus or minus 5% in this class. So in steps 3 through 7, we've balanced on a dry matter basis. That's not how we feed. We got to add the water back mathematically to get our as-fed weights. And that's what we do in step 7. So we list all of our 3 feeds, how much dry matter is coming from each of those feeds. And we calculate our as-fed pounds by doing what? One more time.
Dry matter pounds divided by the dry matter percent.
Yep. Or dry matter over 100, right?
Yeah.
And so the as-fed number, what do we always know about that as-fed number? Should be larger. You've added water, it should be larger. So we have a cheat sheet that you can mark as we go along. So we take numbers from certain sections, we move them down. This gives you a little bit of sheet to show you where everything goes. You can make notes as you go forward. So we're going to take the ration we just did, and we're going to run it through this form. Okay, let's see if I can find that. Okay. So we have our form here. So step 1, we want to determine our requirements. What have we said our requirements are for this animal? Dry matter intake. Dry matter, energy, and protein are what the requirements we're looking for. How many pounds of dry matter are we looking at? Or how many?
15.
15 pounds of dry matter intake. 8 pounds of TDN. 1.9 pounds of crude protein is what we're looking for. So we'll get there and then we do this next. So if we take a look at this filled out, and this is up on Brightspace, if you want to refer to it, this typed out one. So we got a 750-pound animal gaining 1.5 pounds a day. That will give you roughly the requirements that we're dealing with for this animal. So 8 pounds of TDN, 1.9 pounds of crude protein. So I said, assume 2% of body weight is dry matter intake. So how do I figure out 2% of body weight?
How much you say the animal getting per day?
She's getting 2% of her body weight for dry matter intake. So how do I figure out what 2% of her body weight is?
You would multiply 750 by 0.02.
So 2 over 100, 2%, 0.02. So that's going to give you 15. So this 750-pound animal is eating 2% of her body weight on a daily basis, which works out to 15 pounds. So what I will be giving you in a lot of your assignments, I will give you a percent of body weight. You'll have to calculate the dry matter intake for that animal. And then the others, we'll show you how to get those from tables next week. Or the week after, depending on where we are. Okay, so we've got hay, corn, and soybean meal. So which one's going to be our number one feed? Your hay is going to be your forage. If we look at the relative energy, it's lower than the other two. If we look at the protein, it's as low or lower than the other two. So one feed is low and low. Our two feed, our energy feed, is going to be the corn grain. 90% dry matter, high in energy, low in protein. Soybean meal is going to be our third feed, our protein feed. 90% dry matter, high in energy, high in protein. So we've done steps 1 and 2. So I've given you them in this case. Next week, we'll show you how to look up all this information, probably the week after, if we can get to that cow next week. So if we take a look at the ration 1, ration 1, we're going to try just feeding hay. So this pile of feed right here, we're going to try to feed that to the animal and see if that satisfies the requirements. So our feed 1 is hay. We're doing 15 pounds of dry matter intake for our feed. In order to figure out how many pounds a TDN is, we take our pounds of dry matter divided by our percent, or times by our percent, to give us the pounds of that nutrient. So 15 times 40 over 100, or 0.4, is going to give us 6. Does everybody see how to get that? Just like we taught in the beginning of class. So we pull our requirements. Where do we pull those from? Up top, step 1. So it should show that we're bringing those numbers down on our cheat sheets, right? So we're bringing those numbers down. I take this minus this, and I get where I am. So this means here, 6 minus 8 means I'm 2 pounds short. So a negative number there means I have to keep going. So 15 minus 15 is going to be 0. We're right on the dry matter intake. 6 minus 8, we're 2 pounds short for our TDN requirements. So that means we need to proceed to step 4. So step 4, balance for energy by first determining the gain in energy by substituting 1 pound of feed 2 for 1 pound of feed 1. And second, determine the amount of feed 2 that'll make up the energy deficit. So the first ration gets us our dry matter taken care of. We're trying to move through this in a systematic fashion. The next thing we want to take care of is energy. So make sure we get the energy balanced. So how much energy is in 1 pound of feed 2? 0.8. Every pound of corn has 0.8 pounds of energy in it. So we put that 0.8 right in here. So this is lined up so things come down. So this thing here tells you what to put here. This up here tells you what to put here. And then we, by subtraction, we get the next number. So hey, how much TDN, how many pounds of TDN are in 1 pound of hay? 4/10. Every pound of hay has 1, 2, 3, 4/10 of a pound on a dry matter basis of TDN. So for every pound of hay I take out 4/10 of a pound. I put back 8/10 of a pound. Every time I do that substitution of 1 pound for 1 pound, I gain 0.4 pounds of TDN. Take out the hay, bring back the corn. Every time I make that substitution on a per pound basis, on a dry matter basis, I gain 4/10 of a pound. Everybody see that? So I still need 2 pounds of TDN. We take this number here, we bring it down here, we lose the minus sign. I'm 2 pounds short, I still need 2 pounds. So negative to positive. And that can get confusing sometimes, so make sure you're thinking about that. I still need 2 pounds of TDN. Every time I make the swap of pulling out hay and bringing back corn, I gain 4/10. So I'm bringing this down from here to here. I need 2 pounds every time I swap. I gain 4/10. So I need to substitute 4 pounds or 5 pounds of corn in there to make up my energy deficit. Everybody sort of see that. If every time I do 4/10 of a pound, I got to do that 5 times to make up that 2 that I need. So that says I need to substitute in 5 pounds of corn. Our dry matter intake is fixed, so if I bring in 5 pounds of corn, that means the hay's got to go down by 5. So you take your dry matter intake, you subtract 5 for feed 2, the amount of feed 2 we need. So bring this down there to there. That means the remaining pound of feed 1 is now 10 pounds. So let's check that ration. We flip the sheet over. And we'll do our second ration now that we're all set up to do that. We've gone through mathematically to satisfy our energy needs. So our first feed is hay. We're going to use 10 pounds of that. Our second feed is corn. We're going to use 5 pounds of that. we pull the TDN percents and the crude protein percents from the previous page. Just like we did in the beginning of class. If it helps, this is also posted on Brightspace. This PDF is posted on Brightspace. So you're going to multiply 10 times 0.4 to give you what? £4. 5 times 0.8, it's going to give you what? £4. We add those up, 4 and 4, 8 against our requirements. We pulled from the flip side of the page. We have met our energy requirements. We got to figure out our protein pounds provided. So nutrients provided. So we take the dry matter pounds, we multiply it by the crude protein percent, 0.1, 108 or 10 divided by 100. So we're getting 1 pound of crude protein from the hay. Not an insignificant amount. But it's not going to be enough. We take 5, multiply it by 10 over 100. 0.1 is going to give us a ½ pound of protein from the corn. We add those two together, 1.5 pounds. We compare it against our requirement, 1.5 minus 1.9. We are 0.4 of a pound of crude protein short. Everybody see how that gets filled in? If our math is right, when we get to this step, this should be 0 and this should be 0. If we've done step 4 correctly, step 5 should balance for crude protein and energy. Should be 0 or something close to that. Everybody with me? Any questions so far? So we're 0.4 of a pound short. We're not within plus or minus 5%. We're more like 25% off. So we have to keep going. So this time we're going to try to make up our protein. So balanced protein by first determining the gain of protein in pounds by substituting 1 pound of feed 3 for 1 pound of feed 2. Second, determine the amount of feed 3 you need to bring into the diet to make up the deficit. So if we look at feed 3, how many pounds of crude protein are in every pound of feed 3? 5/10, ½ a pound. So half of it, 50% of it, is protein. So 0.5 goes right here. Protein pounds in feed 2. What do we have for that? 1/10, right? So we put 1/10 there. 0.5 minus 0.1 is going to give us 0.4. Every time we take out 1 pound of corn and put back 1 pound of soybean, we gain 0.4 of a pound of protein. Everybody see that? 1, 2. So we're going to keep substituting until we make up the deficit. So 0.4 goes down over here, still needed. Or this 0.4 goes down over here. This 0.4 goes down over here. 0.4 times 0.4 equals 1. So we need to bring 1 pound of soybean meal in to make up the deficit in protein. So 1 pound of feed 3, we have to take that from feed to 2. We're substituting 3 for 2. So we start with the amount of feed 2 from up here, bring that down. We take this from here, bring that down. This becomes our new amount of feed 2. Everybody with me on those? Again, these are up on this filled in version. PDF version is up on Brightspace. If you want, I can print it out and bring it to the next class. So we need to balance down to 3. So confirm that we've balanced for all 3 components, or run trial ration number 3 with feeds 1, 2, and 3. So we've got 1, 2, 3 hay, corn, soybean meal. So what's going to be our dry matter for each of these feeds? What is our hay going to be? 10. Corn.
5. 4.
4. Soybean meal. 1. You're going to pull the requirements or the analysis from the previous page, and you're going to multiply dry matter intake times TDN percent to get pounds of TDN. Dry matter intake times, scooting over to crude protein percent, is going to give you crude protein pounds.
So corn is 4.
Yes, remember we just right up here, we just did this number here to the.
Oh, okay.
So, right, we were at 5 up here. We're gonna make up our deficit by using 1 pound of 3. We're gonna take out 1 pound of corn, put back 1 pound of soybean meal. That leaves 4 pounds in the pile, right? So our pile of feed that's gonna balance out is right there. So we've got something that looks like that. So, and because I made the numbers match up, everything balances out. 0, 0, 0. We have a balanced ration. We are within 5% of requirements. So did everybody notice that this line here for hay is exactly the same as the top line? So everybody see that arrow that I brought down? So you've got the top line in ration 2 is the same as the top line, or the line for hay is the same in both of them. Everybody see that? We haven't changed the amount, we haven't changed the composition of the feeds. So does everybody get that math as we move over? So we've got a balanced ration, 0, 0, 0. We move to step 8. We take our dry matter pounds. We divide by our dry matter percent. That gives us our as fed pounds. So 15 pounds of dry matter is going to work out to almost 17 pounds as fed. We've added the water back into the pile. 11.1 pounds of hay as fed. 4.4 pounds of corn as fed. 1.1 pounds of soybean meal as fed. So it helps me, it seems to balance out. If I go to 1 decimal place with the dry matter intake column, 2 decimal places with the TDN column or energy column, and 3 decimal places with the protein column. Does it matter? Probably not, but that seems to work well for me. 1 for the tens, 2 for the energy, 3 decimal places for the crude protein. Everybody see how those things work together. So we balance the same ration 3 times. 3 different ways. Does one way work better for you than another way? Which representation made the most sense to you? The first one or the second one? First one? First one. So you just have to mentally think about that. I have a pile like this. I'm gonna take some stuff out, bring some stuff back in. Is that pile good enough? If it isn't, and I gotta take some of that out, bring something else in. Is that pile good enough?
Are those old CMPK bottles?
Probably calcium gluconate if I had to guess, but same lines, yep. I'm a cheap bastard, but I tend to
It works.
Better words.
I tend to find ways to make things work on the cheap. I was brought up poor, so.
But true farmer does.
Any questions on that form? So again, this completed form is up on Blackboard. If you prefer to take a picture, I have a printout of same up here. You want to get it all on one sheet of paper instead of doing that, we've got those available there. So, so the cheat sheet, everybody understand all the arrows and stuff? We haven't. This will be there. You can use this up into, but not including the lab practical. You have to balance rations on the lab practical. I will give you the exact same form that you have now. And if you look at it, it tells you all the directions. If you read the directions, follow the directions, it walks you through step by step. So you've got your different there. So that's all I have for today. You can stay here and work on your homework. You can take pictures of whatever you want. You can rearrange this stuff however you want. Think you'll have most of it when I get it posted, hopefully tonight. You'll have all the pictures that I've taken in the past.
Looks like a tax form.
Time is yours to use as you see fit.
What exactly is lab we do? Know what lab what we're doing next week or?
I don't know yet whether we're gonna do a room and dump or not, so,
Okay.
so we will get you caught up when you get back, whatever we do, so.
Gotcha.
Talked to John yesterday. He's of the opinion, no, if we could wait, certainly past this week. Maybe one more week for her wouldn't hurt.
It was rough, especially like a month ago, like how it was. Boy.
So the problem is, it's gonna be after the exam, so that can be a challenge, so.